Hello, everyone, and welcome back for day 6 of Hope 2020. Boy, it's been flying by so far. A big thank you to all our attendees, presenters, and volunteers who've made this virtual session of our conference so successful. Without you, we could not do this and we wouldn't be here. So thank you. We have another incredible round of talks and workshops lined up for you today. Our first session is from Thomas Tempe, a migrant of the global village. Originally from France, Thomas has been living in China for the past 10 years, where he stays active in the hacker and maker communities. Thomas will be talking to us today about the pocket organ, an open source musical instrument. And please remember that we will have a hosted live Q&A session after Thomas's talk with Thomas. So please submit your questions in the Matrix chat window. Take it away, Thomas.
Good day, everybody. My name is Thomas Tempe, and today I will be telling you about the pocket organ, which is my plan for world domination. Here we go, at Hope 2020. Let me start with a question. What is world domination? I say, make me 1 million of these and spread that through the world. That is my wish. My next question is, what is a musical instrument? And the answer is twofold. On the one hand, it's a device for generating sound waves. It makes music. And the other definition is it's a user interface for making music. So if I look at the first definition, if I take, okay, here's a kazoo, can blow air in it, and it makes sounds. And as such, it's subject to all kinds of constraints. Like the size of it is going to determine what kind of sound it can make. If I take a guitar, for example, the length of the instrument is determined by the kind of sound I want to play. And the volume of the instrument is defined by the volume of the sound cavity that makes it resonate at the loudest. So in the end, user interface and learnability and playability are quite secondary considerations. And if I look at the second definition of an instrument, it being a user interface, well, it turns out that most of the instruments you can name today are actually quite ancient in terms of user interface. If you take an electric guitar, it's a modern instrument, but it really mimics or reuses the interface of the traditional guitar. And if you look back at how old is the guitar as a user interface, you'll find out it's centuries old. And likewise, there are very few instruments that you could think of that you can name at the top of your tongue that are modern in terms of user interface. For example, the electric, the MIDI keyboard is mimicking the piano, which is mimicking the clavichord, and the clavichord is a late medieval instrument. This means that, sadly, even a lot of the instruments that we play today, even though they might be electronic instruments, their user interface is defined by manufacturability and sound-making constraints of hundreds of years ago. So when I look at a piano keyboard, the fact that the keys are 26 and so millimeters apart and are perfectly flat, from an ergonomics point of view, it's quite silly. We should know better by now. For example, what about we have a key where you can actually feel the place where your fingers should sit. So this one here is concave. You can feel the side, the right location for your finger, just like a computer keyboard shape, key shape. And in the middle is a small 1 millimeter dot that makes you very aware of whether you put your finger in the right position. And you don't have that on a piano, which I think is a shame. Now that we agree on what is an instrument, let's look at what is a good instrument. And I've laid out a set of criteria here for you, being ease of learning, range. So range means how many octaves you can play. For example, a piano can be very wide, can have 5, 6, 7, 8 octaves. And then if you take a look at a harmonica, it only has like 3 octaves, but not all of them can. The lower octave has holes in it, so it's maybe more like 2.5 octaves. And then accompaniment. So that tells you whether you can play chords with your instrument, like multiple notes at a time, and it can also tell you whether you can use the instrument while singing, which unfortunately for the harmonica again is not possible. So on the other criteria we have, one of them is movability. So this one fits in your pocket, or like a kazoo, it fits in your pocket. If you take a guitar, it fits in a special design bag, and you can take it on your back. The piano, you can take it along when you move, and then the church organ, you cannot take it along even when you move. And then there's one more criteria that I feel is fundamental, and that is expression. So expression determines whether you can modulate the sound they're making. So if I take a piano, I cannot modulate much. All I can do is press stronger or lighter to make more or less, to give more or less loudness to my sound. And the other thing I can do is control the duration of the sound. I press it and then I release it. And that's all. When it's started, when you've let off the sound, you can no longer influence it. But if I take a lot of wind instruments, they are actually incredibly expressive. So take the kazoo. Let's give it a try. Technically, expression is about modulating the pitch, the loudness, and the timbre. But actually, for the musician, it's a way of conveying emotions that's much more powerful than what you can achieve with just the melody. And then it comes to a challenge. If I look at modern electronic music instruments, they're often not very expressive. So I leave out the guitar, the electric guitar, because it really is making sound. It's just like you pick it up with a special purpose microphone. If I look at a lot of the MIDI controllers that are out there, most of them look at the MIDI matrix controllers. So you have a bunch of buttons, and they're usually programmable, which is another way of saying, let's delegate the instrument design part of the device to the user. Like the user has to figure out how to turn a set of buttons into an instrument. And they're usually using on-off buttons. So you turn it, you press it down, it closes the circuit, and then you have a note. And then you release it, and then it opens the circuit, and then the note stops. And that is, you cannot, that is kind of weak in terms of expression. my ambition for the pocket organ is to give it a lot of expression. And it's quite a technical challenge. So it's not working yet, but let me nonetheless give you a demo. Do, do, do. Do, do. So the keys have to have some form of analog detection of where your finger sits and be able to detect if I slide it right a little bit to the side or if I get away from the surface. And this is not working yet. My previous iteration was with pressure sensitive keys. And if you look at like Kickstarter projects, for example, you'll find a few very interesting instruments which are detecting finger pressure. So I moved away from the technology, not that it's bad or unfit for purpose, but it's not very well matched to the very small size of my target size of my instrument. Remember, pocket organ means it should fit in your pocket. And so basically be no larger than a smartphone. And if you want to have pressure sensitive, like a lot of those pressure sensitive sensors, you actually need to give them quite a lot of pressure, which is fine for a bigger instrument, like the Dualo, but it's a little high for something that is so small. There's one more thing I'd like to address regarding a good instrument, and that is whether it is an instrument at all or whether it is a toy. And I think there are a lot of things out there that we would love to be instruments, but actually they are just toys. So let me take one example. So, well, maybe you can think of the stylophone. It's really fun, but you can only play one note at a time, and you need the visual control loop to be able to play. You don't have the tactile control loop. So that means that you can never become virtuose at it. You cannot train your muscle memory to actually play faster or better. So another more obvious example of a toy is the roll-up piano. So maybe you've seen those, and they're just maybe in an airport or on internet. And the idea is just so fabulous. And the sad thing is that the realization is just so shitty. One thing is the delay is hundreds of milliseconds. So between the time you think you've hit the key or your finger thinks it's hit the key and the time your ear hears something, you have way too much time for you to build up the neural pathway for movement automation and muscle memory. And the second thing that is so poorly realized about the roll-up keyboard, the roll-up piano, is that you can never tell from the finger sensation whether you've actually hit the key right or not. Depending on where actually you press, it falls left or right, it's hit or miss. So what makes a real instrument versus a toy? A lot of people just elude the question and go for the most famous instruments. Like you cannot go wrong with a piano, right? Or a violin. I'd like to explore this a little bit. Where do you put the breakpoint between a toy and an instrument? So if you take the harmonica, it really looks like a toy. It's constructed like a toy. It costs, the price point is that of a toy, 10, 20 bucks. It's got 3 octaves, a very small range like a toy, and it's missing, there are holes in the range, like so toyish. And yet, if you look from a musician's perspective, first of all, it has incredible expressivity, and a lot of people have dedicated their whole career to playing the harmonica and gained tremendous recognition from their peers. So from a musician's perspective, it really is an instrument. So in a way, it's a very limited instrument. But didn't those limits stimulate the creativity of the players and make for a greater instrument? Say if you had had a full chromatic harmonica, would it have made the instrument better or worse? And the thing is, we actually have chromatic harmonicas, and not so many people are playing it. So my take on it is that it's fine to embrace constraints when designing an instrument. In a way, the harmonica and the pocket organ are very much alike, be it from the toy-like construction and price point, be it from the continuous expression type of playing, being from the hackability. And so much so actually that the default sound for the pocket organ so far is a reed instrument, like the harmonica. So I don't think I can make an instrument that is as great as the harmonica, but I can certainly make one that is missing some of the holes that the harmonica design is leaving. And one of them is the ability to play it with headphones, and another one is the ability to play as you sing. I certainly will not equal its versatility or expression, but I can certainly do a little better in its ease of learning and the way that it encourages the player's understanding of music theory. It's taken me about a month to get to that point with the guitar, and I think I'm no outlier. So what about we take this time from 1 month to we compress it to 1 hour? Think it's possible? Let's give it a try.
Hey Jude, don't take it bad. Take a sad song and make it better. The minute you take her into your heart, then you can start to make it better.
One question I hear quite often is, why don't you just develop it as an app for your smartphone? And the answer is, actually, you could, but there are a few challenges to this. First of all, that you don't really get a good tactile feedback. You know you hit the screen, but you don't know if you hit in the middle of the key or the side of the key. So one solution could be to have some kind of shell that you clip on top of the screen that gives you this proper finger location information. The next challenge would be to have a good latency, and maybe that would be possible. I haven't experimented with it. I'd be really curious to hear about attempts in this direction. So for now, it will be a mechanical device. If I take a list of all the music that sounds good on a piano, it's practically limitless. But they all take too many fingers to play, like 5 or 10 fingers at the same time. If I take music that you can play on a piano with the first finger, with one finger, it's also limitless, but they don't sound good. So the idea is to pull from the space of music that sounds good, to pull some of them onto the first finger. Right. And that is something that chords can help us do, because chords are this kind of musical atom that just aren't so numerous, aren't so demanding, and sound good, and you can play with a single finger. So once I've had the first finger, then maybe I can have a second finger, and I can put a little more difficult things on it, but that will expand my scope as a musician. So, and in the case of the pocket organ, the answer is I want to put various chord shapes, like the minor key, the sevenths, and so on. And then when I bring it a little higher in terms of player maturity, and I can add some things like sharps, accidentals, and expression.
Let's say I start with a major chord, and then I turn it into a minor chord. Maybe I add a seventh, minor seventh, and then some more exotic chord shapes. Like if I want it augmented or diminished. And you see, increasing chord shapes complexity mean more fingers. Of course, you can still play a melody. Just press the melody button here. And you can have a chord and then melody on top. Not happy with the sound? You can press the instrument key and choose a different, let's say, chromatic percussion. And for a quick drum line, just press the drum button and
Now's the time to mention the looper. The looper lets you record a sequence of notes from one instrument and play them over and over again. Now it gets interesting when you start stacking multiple loops from different instruments on top of each other. The pocket organ lets you record up to 8 different loops, one for each of the buttons here. And then you can turn them on and off at your convenience. And it's built in such a way that they always stay in sync. So even if you turn one loop off and then back on, it will keep playing together with the other loops. in case you're doing accompaniment for singers, you probably don't want to use the looper. They're probably not on time, but you really want to follow them. When you're jamming with friends, however, the looper might actually prove to be very useful because it gives you a very predictable rhythm pattern and chord progression that other musicians can have fun on top of. You might have noticed the metronome ticks as I was recording the loops. So this is a trick to let the instrument know about the musician's rhythm. And it's useful for one thing because it lets the instrument quantize the loop duration so that they always fall very sharply on time. And otherwise, it also lets you do some cool tricks like changing the tempo after recording, and might be useful in the future for things like arpeggios. The screen here allows you to go through multiple levels of menu. Just kidding. It's really about giving you immediate feedback. When you play a chord, it's going to display the name of that chord in big fat capital letters and nothing else. And then when you also do things like setting the volume or other features, it's going to give you immediate feedback. So that means that in terms of UI philosophy, we are also stepping close to the same principle as we had for music discovery. You're going through increasing levels of complexity, including maybe key combinations, and this you get the immediate feedback through the display. So let's have a look inside. The pocket organ is built around a custom PCB with a microcontroller running MicroPython. MicroPython is this fabulous open source project. So when you plug the USB ports into a computer, you instantly see a drive, a USB drive, with all the PY source files in it. So that's the ultimate in hackability. Right now, I'm using the STM32F405 microcontroller, which is a very beefy microcontroller. So the beauty of MicroPython is that I can port to a different microcontroller with very limited porting effort. The PCB also has some embedded memory, an accelerometer, an OLED display, and the rest is capacitive touch sensors for the keys. The keyboard is actually the most tricky part of the project because money just cannot buy you analog buttons that you can use directly on an instrument. You have to somehow make them yourself. In a previous iteration, I used pressure-sensitive silicon keys with something called velostat, which is a piezo-resistive plastic, meaning that the harder you press, the lower the resistance. So you just put a sheet of plastic between the PCB and the silicon keyboard, and you measure an analog resistance. The problem with this technology, it works. Some instruments use it successfully, but the pressure you have to apply to get a detectable signal is actually pretty high. So that's fine for a larger instrument like the Dualo, but it's a little high and not ideally suited for such a small factor instrument as the pocket organ. So now I'm trying to develop a capacitive sensing keyboard. I've taken inspiration from the Silphio, which proves it's possible. They have those very responsive keys. Let me give you a demo. In terms of toolchain, I have 3 different tools that I'm using for the development. First is the code itself. The software is hosted on GitHub along with a page explaining the project. The 3D design, the enclosure, and so on are on Fusion 360, which allowed public sharing and cloning and offer an free hacker license. And the PCB design is hosted on Lichuang EDA, which is the Chinese sister version of Easy EDA, which also offers free hosting and public publication of open source projects. So you can see the PCB, you can clone the project, and you can make your own. Now I'd like to talk about the open source nature of the project. So this is a hardware project, right? When you complete an open source project, that means you've written all the code, fixed all the bugs, published it somewhere on GitHub, and people can just download and use it. But for hardware, that doesn't quite work out, right? You cannot let users download a copy of the instrument and play it. You have to somehow manufacture it before putting it in the hands of individual players. So this is where the million units challenge comes in. For hardware to come to life, you have to have a factory. You have to have suppliers. You have to have a distribution network, marketing. Those are all things that are usually done for profit and not well suited to the scaling down to the level of an individual hacker. Also considering that I have a day job, which I'm not planning to quit. So this puts me in this strange and interesting position of trying to make open source hardware and then developing the project and then handing it over to someone who will take care of all those issues. The typical business case for a novel instrument is high price, low volume. And that's exactly why it's probably not going to make it into the hands of many beginners. In addition, those instruments are monopolies of their respective owners, being protected by patents and copyrights and trademarks. And that's why I believe there is a niche for an open source, low-cost musical instrument. We just have to somehow crack the problem of manufacturing and distribution. There is a crowd that's making very low price, high volume products though, and these are the toy manufacturers. Actually, there's a different crowd, which are the Chinese copycats. So these are not very regarded on intellectual property. They're into making whatever they're making cheaper and higher volume so that they can make more profit. Those people are the ones making millions of roll-up pianos. So why is it that nobody made a good roll-up piano? Well, it turns out the market is already saturated with very cheap roll-up pianos. And they don't care about music. They're just here for the volume. So what if someone was able to serve them with a design that's for something that is a valuable instrument, like the pocket organ, and then their job would be to manufacture it and to sell it at the lowest possible price with the highest possible volume. The challenge with working with copycats is that you cannot really control them. They might be tempted to, say, remove expression just to save on the manufacturing costs. So one solution could be to register the pocket organ brand and then grant its use only to those who respect a specific set of requirements. While I do believe in open source, and I do think it makes the most sense in the design phase, it could actually become a hindrance in looking for a manufacturing partner. So as such, I'm willing to, at one point, close back the source to encourage third parties to invest in manufacturing. If I cannot find a manufacturing partner, then I might just run a limited volume crowdfunding campaign, and then maybe I just do the manufacturing engineering myself, and then I sell assembly jigs for small-scale manufacturers to maybe sell on Tindi. The product itself is actually quite simple to assemble. It's just a one-sided SMT PCB, 2 plastic shells, a battery, and a few screws. And then the cost of the components right now is around $30 per instrument for prototypes. And if I can bring it down to $10 or $12 per for small series for BOM costs, then I can have a shelf price of around $50. That would be my target. And now my call to action. If you're a manufacturer, please contact me. If you want to be an early adopter, maybe play with the product, maybe contribute a few lines of code, be welcome on the GitHub. And if you're really just waiting for an excuse to learn music, you're welcome to follow the project on Facebook, and then you'll be informed whenever it goes on actual sale. In any case, it was my pleasure talking to you. I now wish you a fabulous Hope 2020. Time for the Q&A.
We have 10. Live? Go ahead, you're live.
Hey, thanks, Thomas. That was a fascinating presentation. So tell us, have you always been musically inclined, or what was it that inspired you to really build the pocket organ?
Is it in?
Yep, we're live.
Oh, beautiful. So I'm still hearing myself. Sorry about that. So yeah, I'm one of those guys. I wanted to learn music, but I always got put off by the difficulty of getting into instruments like the piano. And then I always felt like, can't we do things a little better? Like scratching my itch.
And so tell us a little bit how you sourced all the components for the pocket organ. What was that process like? I mean, you live in China, so I assume it's probably a little easier for you than it is for any of us here who would be trying to do that. But tell us a little about that, and then maybe you can give us some advice to people who are looking to manufacture their own devices about how they can get started in that and find the supply chain.
Oh, that's a very interesting question. Actually, I learned about PCB design and so on at the China hackerspace, the Shanghai hackerspace, Xinzhedian, right? And I'm using a Chinese open source friendly EDA, so you can draw your PCB on a web interface. It's very, very well done. And then they have an English version, which I list on my site. It's called Easy EDA. You log in, you select either open source or closed or public or private projects. You design your components, and they're actually linked to a PCB shop. So when you're done, you click send to the PCB shop, and then you can order your PCBs, and they're delivered at home. But that's just the first step. The second thing is, the same shop also does components. They're like a Chinese version of Moser, and they have this huge components database. And because they're the same family, you can actually take the components from their database and place it on your PCB design, and the footprints and the schematics all come ready-made and tested. And it works like very huge time saver. And then you have your BOM, so you can click on the BOM icon and you can order the components. And then I have this even more extraordinary service where you can, they offer SMT for prototyping. And let me say that again. They do SMT pick and place, the robotic, for just 1 or 2 pieces. Normally you start at 1,000, and they do it from 1 or 2 pieces, and the price is just incredibly cheap. It's the same price as normal companies get for high volume production. And in about between the time I click pay on my browser and the time I get the the parts on my doorstep is like 3 days. And I have partly soldered, populated and soldered chips, card PCBs coming to my doorstep. This one has the screen is controlled by me, but most of the other components are made by the SMT actually. And this cost me 300 yuan for two boards. That's like $50.
So do you have to live in China to be able to access that, or is that something that someone from outside of China would be able to take advantage of?
I'm afraid some of those services, like Easy EDA, you can access anywhere, and it's in English. But and I think the PCB service is also offered outside of China. But for the SMT, it's only offered in China, as far as I know. And one of the reasons might be the ROHS and CE regulations, because I have no lead-free certificate or anything. That would be incredibly difficult to offer.
And so any other tips or tricks for people about how to plug into the supply chain there?
That's like, if you speak Chinese, there are a lot of doors open, because you can, like, everything is dematerialized, and you can use a remailer in China to buy things and have them shipped wherever you live. But if you speak Chinese, then you already do that, most likely.
All right, we have a couple of audience questions here. So first of all, question, I noticed you have the sharp symbol on one of the keys, but not the flat symbol. I assume the flat button is for making a note sharp. Why not the equivalent for flat?
Oh, so I just use equal temperaments. So the flat, the C flat would be a B sharp. No, that doesn't work. The C flat would be a B, but the B flat would be a A. You have to, like, I understand that musically the sharp and the flat are not the same thing, but it's kind of an advanced topic.
So it seems one participant in the chat said if kids can learn a recorder in school, they could probably learn the pocket organ. So have you thought about promoting this inside of schools as a tool to help children learn music and music theory and just enjoy playing music instruments?
Well, I'm certain that it would possibly make sense, but my first target is actually like learning through fun. So school children, they have to learn because it's their curriculum. And I guess, like, there is so much inertia in the school system that they probably don't want to change, or unless you have like some kind of like pilot program. I guess getting the instrument out there is really the topic of the last part of my talk is really one of those big open questions, and I don't have the answer yet. So all I know is if I want this to be successful, at some point I have to build a huge community around the instrument. And I don't have money because I'm not expecting to earn any money from the instrument itself. It's just a money sink, not a source. So if like enough people are interested and involved, I'm sure things will happen by themselves. If not, then no. So I understand it takes time to have the community grow, and that's why I'm starting now. That's actually, hope is my bet on finding interested people and having, so I think they call it organic growth, like getting into the movement, and then 2 years down the road, when we have something that's good enough, then people can actually pick it up and play with it.
So this is a really creative exercise, creative project, merging technology and more of the art side, music. So what advice do you have for people who are trying to do something like this on their own?
I don't know. I think that's just how I'm wired, but I guess that's how most of us in that kind of environment are wired. I mean, try to break the silos, go beyond the habits, and then I talk a lot about it to people, and I get like very different answers, or reactions. Some people are just horrified that it's not as good a piano as a piano would be, as a real piano, and then I just ignore them. And then some of those other people are curious about the idea, or I get very enthusiastic responses from people who would like to learn music. And then I try to, actually that's one of one part of the project is actually to get input from other people to incorporate into the instruments. There's no way you can have like a good design if you're designing alone.
So that leads to another question from the audience. Have you ever played a duet with anybody, with 2 or 3 of the pocket organs playing together?
So what I do is I try to go to the local hackerspace jam sessions, and jam sessions have been kind of disturbed with the COVID quarantine and so on. But it's on the plan for the next session to actually bring my working instruments and use it as a background track. And I think that's actually one of the great use cases for it. Unfortunately, the current instrument has too much lag. You don't see it on the video, but it has too much lag to be really pleasant to play. But for using with the looper, then it's perfect.
Someone recommends you TikTok a duet of 2 of the instruments.
Sorry, a TikTok?
Yes, create a TikTok video of a duet with 2 of the instruments to kind of generate interest in.
Actually, yes, I do have other instruments. I can just like record myself and play on top. This is definitely something I can do as a homework. So let's put it like this. I do that as a homework. I put a link on the GitHub, and whoever goes to check it out can have the video.
Oh, fantastic. People would love that. So we've got about 2 minutes left on this Q&A session. Tell us a little bit about how you ended up in China. You started in France, and you ended up as a natively speaking Chinese in China.
Yeah, so I started learning Chinese like 25 years ago, and the first 15 years, because my wife is originally from China, but we met in France. We married there, we started our lives here, we built a straw bale house there. And one day she calls me and says, Thomas, my boss said you go to China. And I'm sorry, I already said yes. So we moved to China, and it was there was a yes or no question for me. Either I was able to learn Chinese to a point where I could find my own job and work for myself, or it was a 3-year expat wife period where I would just stay at home and do whatever and then go home. So I succeeded in learning Chinese to the right level and finding my first job, and then the rest is history.
Well, that's fantastic. And on behalf of all the Hope 2020 attendees and presenters and volunteers, we want to thank you for sharing your passion with us today and enlighten us a little bit about what the process is like to take that idea from something in your head to a physical device, especially given how complicated that can be in this changed world today. And we look forward to seeing what you come up with next. So best of luck. So to the audience, come back at the top of the hour for our next talk, 20 years of scary technology, CityTech's Gravesend End. Until then, keep on hacking. Thank you, Thomas.